So in this first problem, we're going to just do a basic substitution for cosine double angle. Now, cosine double angle has some options, but the one we're going to use should hopefully make some logical sense as we write the rest of the problem. Hopefully you can see that -2 sine squared theta just simply cancels out, and what we have here is 1 equals 2, which of course is false. 1 does not equal 2, and so we get this situation where we get no solution. Let's take a look at that graphically, and let's see why there would be no solution. So what I'm going to do is I'm going to graph each one of these separately, cosine of 2 theta and 2 minus 2 sine squared of theta. So let's take a look here. I've got, you can see in line 1 in purple, I have cosine of 2 theta, and then in orange I have 2 minus 2 sine squared of theta. And let's take a look at a better picture of this here. And you can see that they don't touch. They completely oscillate the same way, and they never touch. So that's why there's no solution, because the solution, of course, would be where they intersect. So let's take a look at our next example. So sine double angle. Sine double angle, we're going to make a substitution here. So 2 sine of theta cosine of theta equals cosine of theta. Now I do this problem on purpose because oftentimes students are really tempted to just cross these out. You cannot do that. And I'm going to show you why you would not get the right answer if you did that. So next step, instead of canceling them out, what you have to do is subtract and get this equal to 0. And then you've got a factor. So you go cosine, and then that's 2 sine theta minus 1 equals 0. And so now we can set each one of these equal to 0. And so if you had just crossed off that cosine in the beginning, like I showed you not to do, you'd basically be missing some answers. You just wouldn't get some of the answers, and you're going to see how there are multiple answers to this problem. So sine of theta has to equal positive 1/2. We know that. And then where does that happen? So let's take a look at where that happens. Let's do cosine of 0. So theta would have to be pi over 2 and 3 pi over 2. And then where's sine of theta? 1/2. So it's got to be pi over 6. And then also in the second quadrant would be 5 pi over 6. So we've got a total of 4 answers. And then let's go back and take a look at a graph again. And that should be apparent if we look at the graph. So I'm going to do sine of 2x and just regular old cosine. And where do they intersect? In between 0 and 2 pi. How often do they intersect? And you should be able to see that pretty well here. We've got an intersection there. There's the pi over 6. There's the pi over 2. There's the 5 pi over 6. And they intersect once again at 3 pi over 2. There's all 4 answers. So you can use technology to, at a minimum, tell you how many answers you're supposed to get, and at best case scenario, you tell you exactly what those answers are. All right, so tan theta equals cotan theta. This is actually a pretty basic problem, and some of you, right off the top of your head, can probably answer this without any algebra. Of course, we're going to go through the proof of all the algebra, but what theta would be the same for tan and cotan? So let's do this algebraically. I'm going to employ a similar tactic, which is get this equal to 0 by subtracting cotan, and then I'm going to turn cotan into 1 over tan. And then I'll get a common denominator. So it'll be tan squared minus 1 all over tan equals 0. And here's the nice thing. Here's something you can do in algebra. So if I were to multiply, for example, both sides by tan theta, it would just cancel out because 0 times anything is 0. So I can actually simplify this problem pretty well. And that's what the problem basically simplifies to. And then, of course, I can just rewrite that as tan squared of theta equals positive 1. And therefore, tan equals plus or minus 1. Just taking the, take the square root of both sides. And that's where the plus or minus will come in. And what that means in terms of the unit circle, that means everywhere. Wherever tan of theta is 1, it's -1 in all of those reference angles all the way around the circle. So pi over 4 is the first answer. That's where tan is 1. And then it's, like I said, it's all of them. So it's 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are those 4 answers. And again, if we want to take a look at that using technology, let's take a look at where tan equals cotan. In between 0 and pi over 2. So we can see we get an intersection there. There's the pi over 4, there's 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, second to last problem. This is our last algebra problem here, and this one is a little complicated. So, double angle. We have a variety of tactics that we can do for double angle for cosine, a variety of substitutions we can make, but that'll be the first one. Now here's the tricky thing. Cosine of 4 theta, here's how we're going to think of it. We're going to think of it as cosine of 2 theta. And what that does is it's going to create this double angle for us, because this part right here, this is the double angle. Double whatever. In this case, it just happens to be 2 theta. But that 2 right there, highlighted, creates this double angle. And so we could rewrite this as, I'm going to do the exact same substitution. So plus 2 cosine squared. Now this time, our argument is not just theta. Our argument is 2 theta, highlighted here. There's our 2 theta. And then we just need a minus 1 equals 0. So in red is the double angle for cosine of 2 theta, and in green is the double angle for cosine of 4 theta, or 2 times 2 theta. So the only thing that you should be changing here is the argument. Green and red should be identical except for the argument. All right, so let's take this a step further. We've got a lot of work to do here. And so let's rewrite. I'm going to rewrite what I have here in green, and I'm going to rewrite it as the quantity squared, because that's actually what squared trig functions are. So I'm going to do that first. I'll just recopy this here. And that will allow us to create a new substitution. So now I'm going to create a substitution for, see, I've got another double angle here. So now what I'm going to do is I'm going to go 2 bracket. Now what is the identity for double angle? It's 2 cosine squared of theta minus 1. So take a look at what I did. Everything that was here highlighted is now inside the bracket. If you just follow the bracket, you can see that was the only substitution that I made there, the only identity that I used, and then I'm just recopying everything. And so this final minus 1 on the end was there, and then of course this was just recopied down there. All right, so now I'm actually going to square. I'm actually going to FOIL this out, and so we're going to start writing a little bit smaller because we're going to run out of room here. So this is going to be 4 cosine to the 4th theta minus 4 cosine squared of theta plus 1. I don't have the squared anymore, but I still have the bracket because I've got this 2 that I'm going to need to eventually distribute. And in fact, I'm going to do that right now. I'm going to be on the road to cleaning this up by simply distributing the 2. So 2 cosine squared of theta minus 1 plus 8 cosine 4th power minus 8 cosine squared plus 2 minus 1 equals 0. And then hopefully you can see that all of this just goes away. That's 2 minus 1 minus 1. And then also, hopefully you can see that I've got a cosine squared and another cosine squared. So I'm going to rewrite this as 8 cosine to the 4th theta minus 6 cosine squared theta equals 0. It actually whittled down to not much. So now let's do a GCF. So I could pull out 2 cosine squared. It's going to be 4 cosine squared minus 3. And then I could just set each one of these equal to 0. Need a theta in there. Okay, and just keep working our way down here. So this is just going to stay 0. If I divide by 2 and take the square root, then nothing's really going to change there. Over here, however, I've got 3/4, and then when I take the square root of both sides, I'm going to get plus or minus the square root of 3 over 2, a familiar unit circle value. So theta is going to be pi over 2 and 3 pi over 2. And then all I have to do is figure out what angle gives me square roots of 3 over 2. And then because it's plus or minus, I get to use every quadrant all the way around the unit circle. So in this case, theta is going to be pi over 6. And then, of course, 5 pi over 6, 7 pi over 6 in the third quadrant, and 11 pi over 6 in the fourth quadrant. So we got 6 answers to this problem. A little complicated. Let's take a look at a graph of this. So here I just have one graph, and really, because it's equal to 0, I'm basically just looking for where it crosses the y-axis. So there's the pi over 6, there's the pi over 2, there's the 5 pi over 6, 7 pi over 6, 3 pi over 2, and finally 11 pi over 6. Those are all our answers once I get to 2 pi. And finally, the last question just says use a calculator to solve, which should be pretty easy by now that we've looked at all of these pictures. So I'm going to have 5 sine x plus x, and then I'm going to have y equals 3. And let's bring this down. I didn't give you the confines of 2 pi, but that's probably just an oversight on my part. We'll just take a look at the values in between 0 and 2 pi as we have been doing for all the others. So these, of course, are going to come out to be true decimals. It's not trig function equals a trig function. It's a trig function with some algebra equal to a constant. And so those are our 3 values, 0.519, 3.177, and 5.71. And the whole point to this is if you can graph 2 things, all you're doing is looking for the intersections.